So today we're going to go back in time a little bit more than usual to 1990 question 4. Now if we look at this question, it's a nice movable pulley question. We have two blocks A and B on a table. There's friction on the table. We're told what it is for B, we're not told what it is for A. And of course we have a movable pulley of 2M. Alright, so if we look through this question, just this good example of why you want to read a question. Show the diagram of the forces on each mass, fine. Solid starting point no matter what we do. But part 2 gets a little bit weirder. If mu is less than 3/4, prove the tension in the string is all of this. Well, that might seem a little bit strange. How do I assume mu is less than 3/4? Well, if you look at the third part of the question, you'll get a hint. Prove that A won't move if mu is greater than 3/4. So what we'll probably find is if mu is at 3/4 is the point at which A can move or not move, where there's enough friction to stop A moving or letting it go. Okay, you can try this very quickly by subbing mu into that equation for tension mg factor of 9 plus 4u, and you'll find out that the tension will equal 3/4 mg. Okay, but if not, it's a fairly solid guess that the system is going to be moving. So let's start off with our force diagrams. It's where we want to start all these things anyway. So there's A. We're told it has a mass of mg. So that is of course our reaction force. There's a string pulling it with tension T. And there's friction opposing it. We're not sure what that is yet, but it's mu or, which is mu mg. Alright, part 1 done. So let's figure out our movable pulley next. There we go, and that's the mass 2m. So it's the same string, so our tension is T in both cases. And it is mass 2m, so the weight is 2 mg. Okay, and finally we'll look at B. B is sitting here. It's being pulled by the same string, tension T. It has a mass of m from the question, mg. And there's a reaction force, of course, or equals mg. And our friction here is, we're told in this case, it's a quarter. So quarter mg. Okay, mu or quarter mg. Part 1 sorted. Now our next step in this one is to go to our F equals ma questions. It's the same place we go in pretty much all of these questions. So let's begin to lay this out. And before we do that, we need to figure out which way it's going to move. So there we are. Here is my lovely black marker. So for the moment, I'm going to assume that this one is going this way with acceleration A. B is going to the left with acceleration B, which means that this is going down with acceleration A plus B over 2. Alright, they all contribute a little bit to it. So that's how we figure out our accelerations and our motions. Doesn't matter if we're actually wrong on this one, we just end up with minus numbers for acceleration. So let's go and figure this one out. So it's going this way, it's going to be T minus mu mg equals ma. In this case, 2 mg minus 2t equals 2m. And our acceleration is, of course, a plus b over 2. And for here, going over this way, so t minus quarter mg equals mb. Alright, now, so we're going to assume it's moving, and we need to figure out the string is this one. So we're going to prove the tension is equal to something. So I want my tensions, I don't want my accelerations. Alright, so what we'll do is we will rearrange. And we're going to get A equals T over M minus UG. Okay, dividing everything by M. This one here, of course, 2mg. Don't always have to touch this one, but in this case, there's a little bit of obvious tidying there to do. Equals m factor of a plus b. Just makes our substitution the next step a tiny bit easier. And of course here, so that's each of those equations, and this one here, b equals t over m minus what is g over 4. Okay, quarter g. So substitute A and B. I end up with 2mg minus 2t equals an m factor of t over m Okay. Next couple of lines are going to be a little bit messy, so just do be careful, don't get ahead of yourself. We'll go step by step and get it all tidied up. Eventually we have t's on one side, everything else on the other side. So what we'll do here is, let's just multiply it all out. 2mg minus 2t equals t. Alright, so now I'm going to put all the t's onto one side. So I'm going to pop them over to here. So I end up with minus 4t equals minus 2mg minus mu mg minus a quarter mg. And I'm just splitting the quarter out here, as you can see how I'm going to simplify this fairly nicely. And at this point, it's always good to go back and double check what you're being asked for. Of course, we do want it as mg up here. Alright, so it'll work out very nicely. Those are minuses because they're only going to annoy us. And we end up with 40. We'll squeeze this one in the bottom here. 40 equals 2mg plus a quarter mg minus mu mg. Now, plus, and that is exactly why, even though the step was a little bit tedious, I did give it its own line of it, a line all to itself, because it is so easy to make a mistake at that level. Alright, so we'll just come across to here. So we'll combine these guys here, so 4t equals, there we are, 2mg, so that's going to be 9 over 4 plus mu mg. Alright, now we're getting into the right track. Keep an eye on things as what we're supposed to be getting to. So t in this case equals 9 over 16. 9 over 16 plus mu over 4 all by mg, and a small bit of rearrangement. We're going to have a common denominator of 16 there. So t equals mg factor of 9 plus 4 mu all over 16, just as asked. And there we have it. Now, I think we're going to fit part 3 in right up here, because actually part 3 is not too bad. So, we're being asked to prove that A won't move if mu is greater than that. Well, A will move if the tension, okay, so the net force on us, we come back over here, this is our net force, if T minus mu g mg is greater than 0. So if there's an overall net force on it, it moves. If not, it doesn't. So what we want, that's what we want to prove. So let's sub in for T. Mg factor of 9 plus 4 mu over 16. There we go. And I've just done a tiny rearrangement, and this will make sense in a moment. Minus mu mg is greater than 0, because the obvious thing to cancel out here are the mg's. So this gets a little nicer straight away. Let's multiply this one out. 9 over 16, because I have to bring that mu into it, plus 4 mu over 16 minus mu is greater than 0. Combine these two guys. 9 over 16 minus 12 over 16 mu greater than 0. So now we can bring this over here. 9 over 16 is greater than 12 over 16 mu. Let's just simplify everything here. So what we're going to find is, we're looking for a quarter, so we'll actually divide everything here by 3/4. So if that's a little bit confusing to you, we'll do it in 2 steps. We end up with 3 over 16 is 4/16 mu. And that one there, of course, is 1/4. So we'll divide it by 4. It ends up being mu. So I'll do it here just to lay it out a bit more clearly. 3/4. That's the mu. Alright? And that's just what we're asked to prove. Okay. Sorry, actually speaking, that's not strictly what we're asked for. We're asked to prove that mu is greater than that one. But what we're showing here is that it will move with this one. Of course, it won't move. We'll flip this around. So it will move. I just was slightly guilty of not fully reading the question, but we can flip this very easily. If mu is less than 3/4, therefore won't move. If mu is greater than 3/4. Small little twist. Do kind of check these little small details at the end. All right.